Here's the basic power rule. This is the single rule you'll use more than any other in the entire course. Basically, it works like this. If you take the derivative of a variable to a power, what you basically do is take this power and move it down in front and then subtract 1 from that power. Let me show you an example. The derivative of x cubed would be 3x squared, because what you would literally do, there's my original function, is I would take this 3, move it down in front, that's why I had a 3, and then I subtract 1 from the power, would leave me with a 2. You're going to use this power rule over and over and over again. It's crucial that if you don't learn anything else, you've got to have that rule just automatically down, almost frankly to the point where you don't think about it. Here's the next rule. Now, the book tries to make this so complicated, and it's really not, but basically, if you have the derivative of a constant times a function, that's equal to the constant times the derivative of the function. That sounds so complicated, but here's what's really happening. Let's say that you have the derivative of 3x to the 5th. What I want you to do is sort of separate that 3 out. Literally look at it like it's this. I have 3x to the 5th. I just take that 3, set it off to the side for a minute, and then take the derivative of just the x to the 5th, which would leave me 5x to the 4th. Then at that point, I merely have to take my 3 times my 5x to the 4th, and I have 15x to the 4th. So it's pretty simple. You just take that 3 and more or less ignore it like it's not there, and take the derivative of x to the 5th. Now, to be honest, a lot of you in high school learned this shortcut, and I'm going to use it from now on, but you need to realize what the real rule is, the idea that you can ignore that constant and just set it off to the side. But here's the shortcut. Anytime you want, you can end up taking that 3 times 5, because that's what you're going to do anyway. So take the power times the coefficient, leaves us with a 15, and then subtract 1 from the power. Let's take a look at our next rule. Once again, the book is really trying to make this complicated. In fairness to the authors, I don't know that in writing you could make this less complicated. But here's the basic premise. If you take the derivative of 2 functions added together, that equals the derivative of the first function plus the derivative of the second function. Here's what that's really saying. Let's say that I had the derivative of both the functions that I already did previously here. In other words, I have the derivative of my 3x to the 5th plus my x to the 3rd. What you'll literally do is take the derivative of 3x to the 5th, which would be 15x to the 4th. Remember the shortcut? 3 times 5 is 15. Subtract 1 from the power. And the derivative of x cubed, move the 3 down in front, subtract 1 from the power, gives me 3x squared. So it doesn't matter how many terms you have, you literally just take the derivative of each and every term in the sequence. Now, here's a couple particulars that probably are going to be pretty obvious to you. If you've got f of x, or the function of x, so that it equals some constant k, then the derivative of that constant is 0. Well, think about that for a minute. What are we really saying? We're saying that if f of x always equals 5, in other words, if x is 0 equals 5, if x is 1 it equals 5, if x is 2 equals 5, etc., 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 it always equals 5. Well, if it always equals 5, remember the derivative is the change, right? Well, if it always equals 5, it's never changing, so it kind of makes sense to me that the derivative of that would equal 0. It's never changing, so the change is 0. You could actually use your power rule again, though. You could think of this as 5x to the 0. Because there's no x's there, right? There's literally 0 x's there. Or if you prefer, anything to the 0 power is 1, so 5 times 1 is 5. So this is the same thing. Now I've got my variable that I needed in order to take my derivative with respect to x, by the way. 0 times 5, of course, would be 0. Subtract 1 from the power, I guess, would give me x to the minus 1, but 0 times x to the minus 1 would just be 0. To be honest, I'm happier if you just see that the derivative of this is 0, because it's a constant. It's never changing. It never goes up or down, so the change is 0. Therefore, of course, the derivative is 0. The next rule is this. If f of x equals mx plus b, in other words, I hope you recognize that's a straight line, then the derivative of x equals the slope. Well, of course it does. How many times have I told you so far this quarter that the derivative is the same thing of slope? So of course the derivative equals the slope. But let's go ahead and look at an example. What I'm saying is if we have the line 4x plus 3, the derivative would be 4. Well, let's think about this for a minute. That really says 4x plus, to the 1 plus the 3. Use your power rule. 1 times 4 is 4 times x to the 0. And of course the derivative of a constant is 0. So 4 times anything to the 0 power is 1. 4 times 1 is 4. Plus 0, of course, is 4. So you could, once again, just continue using all the rules. These are just special cases. But once again, I'm happier if you just see that, of course, the derivative is the slope. So when I ask you to take the derivative of a straight line, it has a constant slope, so of course the derivative is that slope. Hopefully that just makes sense to you. Finally, let's do a couple more examples. Find the derivative of x if this is my equation. In other words, notice the x is in the denominator. Well, the first thing you want to do, frankly, is take that x to the 5 and move it up and make it an x to the negative 5. Remember, anytime you move from top to bottom, you nearly have to change the sign on the power. 3x to the negative 5, let's use our power rule. 5 times negative 3, oh look at me, that should be a negative 15. And then subtract 1 from the power would be negative 6. So my answer should have been listed negative 15 x to the negative 6. Let's try another one. This one looks a whole lot more complicated, but actually it's not. What if my function was 3 times the 7th root of x to the 5th? Again, I want you to find the derivative. Well, first of all, I need you to write that as a power so that we can even use the power rule. I want you to pull that 3 out in front, and I want you to think of this as the 5/7 power. So this basically is the 5/7, right? And it just occurs to me back here, I can't believe I did this. I never actually showed you the derivative. I was just merely listing the function there, and I never said that this was the derivative. This was the function, this was the derivative. I trust that was clear to everybody, and I just made a mistake there, and I hope you'll forgive me for it. Let's take one last look at my last example. I apologize again. Let's take a look here. We had 3 times x to the 5/7 power, because I wrote this as a 5/7 power. So 3 times x to the 5/7. Let's use our power rule. We'll take the 5/7 times 3 would give me 15/7. Subtract 1 from my exponent. 5/7 minus 1 would be x to the negative 2/7. Now, to be honest, that's going to be fine with me. I suppose you could move that negative power down to the bottom, make it positive, and do all those sorts of things. But I'm not going to worry about it. Frankly, if you can get to this point, I'm going to be happy.